So recently we've spent some time looking at how to deal with vectors in 2 dimensions and could potentially be extended to more dimensions. And prior to that we spent a lot of time looking at some quantities relating to kinematics, like position, and of course the change in position, displacement, velocity, and acceleration. And we said that in all cases, all of these quantities are vectors. But so far we've only been treating them in 1 dimension, so their status of being a vector just means they're either pointing right or left. They're either pointing up or down, basically either positive or negative. We're now going to go into a more generalized treatment of them, where we treat them in being in 2 or 3 dimensions. For example, if this is some 2-dimensional plane my object is moving in, if I had initial velocity that were, say, up and to the right, it's not as simple as just treating its magnitude as being positive or negative. We've looked at, in general, how to handle vectors like this by breaking them down into components. And we've looked at plenty of examples of doing that. Well, now we'll see how this entire process of handling vectors in more than 1 dimension applies to kinematics. But before we do that, I want to define one thing that's going to be a little bit different than what we've looked at before. Up until now for position, we've been looking at 1-dimensional motion, and so we simply used an X to stand for position if we were talking about an object moving horizontally, or we would use a Y for the position value if object was moving vertically, and we haven't really been looking at Z direction motion, but you would imagine we could use a Z. Well, for objects that are moving in 2 or 3 dimensions, we can't simply use just an X or just a Y or just a Z to represent the position. We need something that could represent any or all of them at the same time. And so from here on out, we're going to represent position in a general sense by a vector R. And R will be the position vector. It's defined exactly how we define the general position vector, which is it's a vector that points from the origin to where a point is located, whether it's on the x-axis, the y-axis, the z-axis, or some combination thereof. Now, the important thing to keep in mind about this R vector, this is still the position that we've looked at before. Its x component is simply the x position vector that we've been using all this time, and its y component is the y position vector. R is just a shorthand to represent any or all of them, particularly if we might be moving in 1 or more dimensions at the same time.